look how it's labeled. It's the line, good. And so we're going to be looking to find 4 on the line. And so I'm going to go ahead and just highlight it here with the red line. Go out to 1, 2, 3, 4, and we'll go up to the point. What value is that? 1, right? That's 1, right? So I'm going to do f of 1, right? And we'll go ahead, because remember 4, 1, 2, this is 4, and we went up to 1, right? Now we're going to go to 1 on f, 1, and it comes down to here. What value is that? 1, 2, 3, -4. Good, so that would be the answer, right? Okay. Now I can't really erase these because I want to erase the graphs as well, so I'll just use a different color to do letter B. How do I start with that one, Jennifer? Let Jennifer tell me, and then I'll come back to you. F of 1, okay, F of 1, oh, F of 1. We already know that to be -4, right? So we have G of -4. Travis, what do I do from here? Shh, what do I do from here? That's not on your homework. What do I do? I found F of 1 to be -4 because we knew that F of 1 is -4. How do I find G of -4? I don't make it a positive. Help him out for me. Go ahead, Angela. What do I do? On the line. So I look at the line because that's G. So I'm going to go 1, 2, 3, -4. And I'm going to look up here. And what value is that? 1, 2, 3, 4. Looks like that's 5. So that would be my answer. Okay? You just plug one, and then you plug that answer into the other. That's really all it is. That's what composition is. Finding one value and plugging it into the other and finding the other value. Because that's F of 1. This value right here, we just found it to be -4. I just replaced it with -4.
So we just put -4, right?
Uh-huh. We already did that. All right, so let's go ahead and change, because G of -4, I'm looking at G now. -4, I go up to the graph, and that's up here at 5. All right? Okay. If we could, let's go ahead and change, look at number 18 now. Just for time's sake, we don't need to. Can you guys get your worksheet out? I'm going to hand back those of you who handed it to me already, so you can make these corrections to number 18. Show me.
I needed that homework. I needed that for the homework yesterday.
All right, so the mistake that I actually made was with part A. So if everybody could go and look at part A for me. I made a mistake, okay? And the mistake that I made, okay, soon. So it says, write a function to represent the price per video game after the store's markup. So f of x is just 1.25x. We wrote that, right? Okay, so that one wasn't actually the mistake. It was actually part B was where the error was. Okay, so everyone should have had part A correct, right? If you look at part B, it says write a function to represent the manufacturer's cost plus the shipping charge. It doesn't say markup there, does it? So that's where the mistake is that I made when I gave you the function, okay? So the actual function for G of x is just x, because that's the manufacturer's cost, plus the shipping charge, okay? So please make sure that you, I wish you would have said it yesterday, or whatever, I don't even know what day it is, Tuesday? That was my mistake, okay? So it's just the cost, it's just the shipping charge is one, and the markup is the other. So would you please go back and fix C and D when you do your f of g of x and your g of f of x using these functions? Okay, so I'll give you a couple of minutes to adjust your answers for those. Because if you remember, C, we had to do f of g of x, and D, you had to do the two different compositions. That's not different. It's just that your G is going to be different. That's all. So just go back and fix those. So give you a couple minutes while I put attendance in for you guys to make those adjustments, and then I will collect your 6-6 worksheet, okay? So you guys said you wanted to go over the homework here and look at page number 34. Are there any others? Would you like to go over 46? Okay. Since that's the one I graded, that was that word problem. Any others? One more?
36.
36? Sure, we'll pick that one. All right, so let's start with 34, okay? In problem 34, you were asked to find h of A, Kind of strange the way that notation looked in the book. Did the A's throw you guys off at all? Just, I told you beforehand, just treat it like an X, right? So nothing really any different. Let me go ahead and tell you what H is so you know. H of X was X squared plus 4. Okay? So it said we needed to compose this with itself. So that just means H of A. Question, April? I thought you said Miss Mackert. No? Oh, you said. Okay, correct. Is it G of G? 34? No, it's H of H. Okay. It's H of H, right? Okay, your book said that? Just maybe you just wrote it down wrong. All right, so here we're going to go ahead and just plug in an A for X, no big thing. And you're just going to say A squared plus 4. Just replacing the A for the X. That's all we really had to do. And now we have to go ahead and plug this into H again. So I'm going to write H, X squared plus 4. Well, what goes in X squared? Plus, what goes in the X? A squared. So that's, did anyone leave their answer like that? Okay, so that would have gotten you partial credit, okay? Why am I not finished? And I keep using Shamar as the example because he asked such a great question last time. How do I know I'm done simplifying? And that's a good point. One of the keys to knowing that you're actually done simplifying is if there are any exponents outside of the parentheses, you need to address those. Okay, you need to simplify that. So that's one clue that you're not done. Fair enough? So let's address that. Let's go ahead and simplify just this part, and then we'll worry about the plus 4. Okay? So we'll do some side work. A squared plus 4, quantity squared, is just A squared plus 4 twice. Do you agree with that? Okay. So now we have to do what? What does it look like we need to do it? Right. Now we got to multiply. Okay. That's where A to the 4th comes in. So I have A to the 4th. We should have gotten plus 4A squared plus 4A squared plus 16. So combining my like terms, I should get A to the 4th plus 8A squared plus 16. And then I still have that plus 4. Right? So that's where the 20 came from. So my final answer was this. Okay? So again, if you left your answer where I have it highlighted, that will get you partial credit because you did show that you composed them. You just didn't simplify all the way.
Right.
Okay? Any other questions on 34? Plus 4 is part of the problem. Here? Because I had to, so at this point, I just wrote at H. I wrote parentheses squared plus 4, parentheses squared plus 4. And then I plugged in the A squared plus 4. So the plus 4 came from the original problem. Okay? All right, what other one did you guys say you wanted to look at? 36? All right, let's look at that one. So 36, we have two different functions here. We have g of x is x squared. And you have that f of x, I'm sorry, wrong way. F of x is x squared. Wrote it down wrong. And then you have g of x was x minus 3. And in 36, you're trying to find g of f of negative 2. Right? What do I do? Let's tell Chris, since he hasn't been here in a month. I got to find, and what do you mean by I have to find f first? You're on the right track, but say what you mean. What do I do with the f? Right, I have to evaluate it at negative 2. That you both are saying the right things together. Okay, so I'm going to put a negative 2 in parentheses into f. So I'm going to start finding f of negative 2. F of negative 2 is x squared, but what goes inside it is negative 2. And Alexis, when you square negative, it becomes a perfect. So the answer is just 4.
Wow.
Now hang on, I'm not done. Did you forget to square the negative?
No, I couldn't.
That's why. You forgot to get the positive, right? Now I'm going to plug that 4 into g and find g of 4. And that becomes 4 minus 3, and that's how my answer became 1. So it's that negative issue. Don't forget to square your negatives. All right, last one that you guys want to look at is number 46, and it was a word problem. And it had to do with pesos and Chinese currency, I believe. So it said, suppose that this function f of x represents the number of US dollars equivalent to the Chinese yuan? Is that right? I thought it was yen, but maybe it's the way it's spelled.
Our money's that much to Chinese?
Yeah, the number of US dollars equivalent to one of them. Yes, there's a lot of yen going to them.
So if they were like to come over here, they have bread.
No, because they wouldn't make as much money. It's the other way around. All right.
We got more money than them.
Yes.
Oh, we got more money.
Okay. Not everybody, because here, look. Actually, it is the other way around. But we're not in euros, honey. This is Chinese. This is not a yen. I'm not sure what this. Can we move on? All right. Now we have boys. All right. Now we have pesos, and we do know that there are a lot of pesos per $1. And in this case, it's 14 pesos make up $1. Okay? That's what it said. Okay? So now we need to answer the question. We're given that information. It says to write a composite function that represents the number of Mexican pesos equivalent to Chinese yuan. I don't think I'm pronouncing that right. Okay? And that's just going to be g of f of x for part A. We're going to compose one with the other. So I'm going to say, okay, I'm going to take g, my outer layer, 14.07. Rather than y, I'm going to put parentheses. What goes inside the y is f of x, so I'm going to have 0.15x. I'm just going to simply multiply those, because that's all it tells me to do. And I'm going to multiply 14.07 times 0.15. Times 0.15. And I get 2.1105. So that is the function that I'm looking for. So that would be part A. And then part B, I had to evaluate it. And it said, find the value in Mexican pesos of an item that costs 15 Chinese yen. Is it yen? Even though I thought yen was Y-E-N. But that's all right. And it was 15, right? Yeah. So I'm going to plug in a 15, and we'll go from there. So 2.1105 times 15. And I get 31.66. So you rounded it to the near, that's what I told you. You rounded it to the nearest peso. Okay. Just plugged it into the function. Put it on my desk for me, Eduardo, okay? All right. No other questions on homework? Yes, I'll give you the review. All right, here we go. So we're going to finish up our unit, and we're going to talk about what are called functions. Christopher, shh. Inverse functions. There's a little notation stuff we got to talk about first, and I really want you to pay attention to this because a lot of people get this confused with something else. So I want you to look up at the notation. Notice that it says the word inverse, so that's what we know it's going to be, but look at what the inverse notation looks like. It looks like it's an exponent, doesn't it? But it's not. Okay? When that little -1 is up there, and I'm going to write this so you really recognize, when we're talking about function notation, this does not mean that. Don't you remember that when we did negative exponents earlier in the year, that was a reciprocal, you put it in the opposite part? Well, that's because this is not an exponent, okay? If it was an exponent, I would agree. But when we're talking about functions, that little -1 really means inverse, okay? Oftentimes it's written like this, where the x is going to be there, so it's like f of x was the same thing as y, right? Well, f -1 or f inverse, we don't say -1, we really say that, that's even red, f inverse of x. But because it has sometimes in math, the same number means two different things, and that's what this is. So try not to let that confuse you, okay? This just means inverse. That's all it means. Now, if two things are inverses of each other, okay, then one point would be xy, The other point would be yx. They're inverses of each other because their coordinates switch. Okay? Another way to look at it from a geometric point of view, and I'll try to turn the lights out so you guys can see this a little bit better. We know what the line y equals x looks like. This is the dotted line, Nate. Y equals x, right here. And if I took this function, I'll highlight it in green since it's in green, this function right here, well, I wanted to make it a curve because it's part of a parabola. If you can kind of see, it is curved there, okay? If I take this part of the parabola and I reflect it across that line, that dotted line. Remember from geometry, when you took geometry, you reflected across this line. When you reflect it, it actually changes, and it now comes this way. Okay? Now, you know where it is. The one down there, the red one. Okay? You can kind of visualize if I was to put those two things together. If something is facing up, like this would be facing up, it's a function right now. Would you agree?
Yeah.
But if I reflect it across the line y equals x, is it still a function?
No.
Okay? So that's something you have to think about. Okay? So oftentimes we talk about half of parabolas for that reason, so that they're still going to be functions. But really important, they reflect across this line. In other words, the point 0, 4 would become what point now? 4, 0, and it does. Look, 4, 0. Pick another point. I don't care. Let's pick 2, 8. What would that point become on the inverse? 8, 2, and look, it does. Okay, so every point on the original function, if this was f of x, then its inverse would simply be the x and y coordinates are switching. Okay, it's that easy. So we're going to practice. Okay, I want you to go ahead and graph on your paper. If you need to just do a little sketch, that's okay. But I want you to graph x squared plus 3, and then I want you to graph its inverse. If you need your calculator to help you, that's fine. But what does x squared plus 3 look like, and how do I graph its inverse? So you guys know that x squared plus 3 is an upright parabola that's moved up 3 units. We know from our parent function days, the beginning of the year, to graph this, you go right 1 up 1, left 1 up 1, right 2 up 4, and left 2 up 4. And we know that this is the graph of x squared plus 3. I want us to find the inverse graphically. What would I do if all I had was the graph and I had these 5 points? What would I do? Did I give you the sheet? Say that again, Patrick? Okay, and so tell me some of the coordinates that would be on the inverse graph. Perfect. So I'm going to graph the point 3, 0. Good. Give me another set of coordinates. Angela, give me another pair that would be on there. Okay, so 1, 4 is currently on there, so now it would be 4, 1. Good. If I remember the pattern, I can just use the pattern. Rather than right 1, up 1 from the vertex, we'll go up 1, right. We'll just kind of continue this pattern sideways, and we can go ahead and graph it from that perspective. Or if you just want to do 1 by 1, that's okay too. But that would be the inverse. Okay? Upright parabolas, their inverses are sideways parabolas. Okay? Anything orientation-wise, if it goes this way, when you reflect it across that diagonal line, it does have a different orientation. So we have lots of functions that we can reflect, or that we can find inverses of. Parabolas are one. We'll go ahead and find the equations of those in a couple of minutes, but for now, we're just going to practice with the graphs. Here's another one. This is no longer a parabola. It's a square root function. What does this function look like graphically? You can use your calculator if you need to, but let's practice this one. What does that minus 2 under the radical transformationally tell me to do? Up, down, left, or right? Right how many? Good. So we are remembering these things. So I am going to go right 2. And then we're going to find some points to graph it from here. So hopefully this is what you found. I want you to be very specific about some of your coordinates. Again, use your table if you need to on your calculator. Plug it in. You should see the point 2, 0. There are going to be some errors in the negatives because there is no part of the graph that's in the negative. So you just want to scroll down until you see some of the positive values. So 2, 0, 6, 2. Okay? But you're exactly right. Because you can't have a negative under the square root, right, April? So that's going to be a domain restriction. All right, so here's the parent. Here's our f of x. How do I find the inverse? What do I do? Joseph, give me some points that are going to be on the graph of the inverse. If 2, 0 is on it, give me a point that's going to be on it on the inverse. Okay, so I'm going to graph 0, 2. Good. Give me another set of points, Carolina. 1, 3. All right, Alexis, give me one more. You can do it. 6, 2. So what would it be? 2, 6. Good. All right, so the red graph is going to be the inverse function. Notice that little -1 does mean inverse. Okay? I think we can do, the graph's not bad, right? You can use your calculator to find your original function. I just want you to find some exact coordinates, and all you have to do is switch them. It's that easy. Nothing too bad. What if I gave you the graph already? Wouldn't that be even easier? Right? This is a strange function. I'm not sure you can even see it. Can you see it? That kind of? Let me highlight it a little bit. These are some of the points that I picked specifically. This is not, first of all, is it a function, yes or no? How do you know? Because it passes the vertical line test. The x's don't repeat. Remember all these things? You're going to have to remember this for your quiz next Monday. Okay? So how would I graph it? I don't have the line y equals x, but let's say that that was my inverse. Sometimes you do y inverse, but I'll stick with my function notation. Let's graph the inverse. So Christian, let's start up here. This is the point 0, 1, 2, 3, 4, 5. 0, 5 is part of the original function. What's on the inverse? Good. There we go. All right. I don't think that one's going to show up real good. We'll reuse ref. All right. Gabby, give me another one. 1, 1 stays on it. Is it okay that the graph doesn't, that point didn't move? Well, isn't it on the line of reflection? Right? So if it's on that line, it's not going to move. And that's okay. Trying to get that line off. All right, give me another one. Travis, give me another one. So far we've moved this point and this point. Give me another point we're going to move. This one's 2, 0. What's it now going to become? Good. All right.
They can intersect.
They can. And I'll show you why in a minute. Luis, give me another one. Well, and right now it's 3, -1. So on the inverse, it's going to be -1, 3. Good. All right. Keep going. Nate, give me another one. I think we only have one left. One down at the bottom. Can you count? Let's see. Looks like it's 4 and -4. Perfect. All right. So I'm going to go ahead and just kind of curve these. Does that look like inverses to you? Well, if I was going to graph the line y equals x on there, doesn't it look like the yellow flips with the red? But drawing that line helped, didn't it? It does for me too. So I can really see that reflection. All these things are possible on your quiz, okay? Give you the equation, graph the inverse, give you a graph the inverse, that kind of thing. But let's do it for algebraically. So you need to write this part down in your notes. Okay? All right, so go ahead and get your notes, finish with your notes. We're going to leave the graphs for a little bit, and we're going to talk about how to write the inverse function in terms of an equation. Okay? So let's start with this one. All right, so here's our function. Look at the equation. Somebody tell me what kind of equation, if I was going to graph it, don't graph it, but if I was going to sketch the graph, tell me what shape it would have. Would it be a V? Would it be a U, like a parabola? Would it be a square root function or just a function? Would it be a rational function? You think it's a What does a have? It has a square root in it. Does that have a square root? Okay, so it's not that. Why is it not a V function? It's not absolute value. Absolute values are V functions. It's not parabola because, I agree, Shamar. Okay, I think it's probably going to be linear. Okay, good. There's no exponents, there's no absolute value, and there's no radicals. So you're right. Okay, and there's no x's in the bottom, so there's no asymptotes or anything like that. It's just a line. So let's start with this function. I want to be able to find the inverse of it, the equation. What do I need to do? Well, the first thing I'm going to do is rewrite y instead of f of x. We all know that means the same thing, right? Y is the same thing as f of x, so we're going to do that. So that's going to be your first step, really. Just replace y with f of x. Angela, you should probably write this down, babe. Haven't done anything to the numbers yet. All I've done is replace the y with the x. I'm sorry, with the f of x. Now, think back to the graph for a minute. What did I do with the graph to find the inverse? With those coordinates, what did I do with them? Rather than 2, 3, I made it become what? 3, 2. So what did I actually do? I switched what? I switched the x and the y, didn't I? So that's what I'm going to do in the equation. That's it. So I'm going to go ahead and switch the variables. I'm going to replace the x with the y and the y with the x, because that's how we find the inverse. Okay? So I'm just going to switch them. Doing this alone will get you partial credit, but on the SOL, you'll never see it written like that. They actually want you to solve this for y. Okay, so we'll have to do that part too. Once we switch the variables, now we're going to go ahead and solve for the y, because y equals is normally how equations are written, if we wanted to graph them or whatnot. So how would I begin to solve this for y? What would I have to do first? How would I get rid of the 2? Multiply by 2. That's what we're going to do. I'm going to multiply both sides by 2 here. Okay? So I multiplied both sides by 2. Any questions on where that came from? When I multiply the right-hand side by 2, it cancels. And the left-hand side by 2, it stays with the x. I got rid of the 2. I'm still trying to get y by itself, so what's my next step? I got to get rid of the what number, the 5 or the negative 3? The 5 is next. So am I going to add it, subtract it, multiply it, or divide it? Subtract, because it's positive, right? So I'm going to subtract it from both sides. When I subtract it from both sides, well, they didn't do that. They wrote something else. I'm going to do it my way. And that's okay, which is still fine too, but we'll go ahead and do it our way. So we're going to say 2x minus 5 equals negative 3y. You okay with that? Now what? Divide by negative 3. Good. So when I divide by negative 3, I get y equals 2x minus 5 over negative 3. A lot of times we don't write the negative in the bottom. A lot of times we divide through by the negative. And if I do that, I get negative 2x plus 5 over 3 is equal to y. I would actually accept either of those two answers, but I will tell you that you will most likely see it written in the blue format, okay? Very rarely will you see it written like it is in the red. We really shouldn't have negatives in our denominators to avoid it. So I just multiplied everything through by a negative, that's all, to change the sign. Okay? And that is the inverse. So oftentimes we write it like this. The inverse of f of x was negative 2x plus 5 all over 3. So since we started out with inverse notation, we can end it with it. Wow, purple? No. So that would be okay as well. Well, because of the gray thing, it looks different, so I'd rather not move the gray thing, to be honest with you. Well, the steps just say solve for y. That's what we did. It's just because they solved y in a different way. It's fine. I can go ahead and leave it there. Do you recognize this as being, oops, sorry. Do you recognize this as being the same thing as this? Two blue things, aren't they the same? So either way that you write that is okay as well, okay? Because the negative goes with the 2x, not the 5. All right. You want to try one on your own? Find the equation, okay? So let's try one. Find the inverse of this one. Find the inverse of f of x. We're going to do two of them. Yes, honey. Okay, maybe I can help you here, okay? So follow along with what I'm doing and you can check what you did. First thing is to substitute the y for f of x. I agree. I think all of us can do that part. I even think all of us can switch the x and the y, right? Because we're going to find the inverse. So to find that inverse, we're going to go ahead and switch the x and the y. Again, I told you would get partial credit just for doing that alone, right? But to simplify, because very rarely will you see it written like this, you have to solve for y, because that's how we write equations. What am I going to do first to solve for y? Yes. What do I do to do that? Yeah, add 4 to both sides. So when I add 4 to both sides, it cancels on the right-hand side, so I'm left with the y cubed over there, and I have x plus 4 over here. Now, Shone, what do I do to solve for y? Cube root, right. To solve for y, I need to take the cube root of both sides. That's exactly right. Cube root, cube root. So the inverse function, I'm going to go ahead and just rewrite it, is the cube root of x plus 4. Excellent job. We got rid of the 4. When I have y cubed and I want to solve for y, you just simply do the inverse, which happens to be the cube root. Very good. Excellent. All right, let's try one more together. Make sure that 3 is there, by the way. That index of 3 is really important. It's not square root. It's definitely cube root. Okay? All right, last one, and then we'll talk about what's on your quiz. Or quest, or twiz, whatever you want to call it. Okay? Does the h bother you? Shouldn't. H of x is still going to be what? Chris, Moraz. Don't distract other people. So why? Because you're talking while I'm talking. It's disrespectful. Your drill sergeant won't like that. Let's practice. H of x means what? Travis, you already told me. Why? Let's replace it. Raul, once I've gone ahead and replaced f of x with y, if I'm trying to find the inverse, which is what I've asked you to do here, What do I do next? So tell me what I would write. No. Okay, so you said it right in terms of you switch the x and the y. I totally agree, but you're going to use the exact same equation. This one right here. And you're going to apply x equals. And you're just going to replace this with an x. Oh, what did I just do? You're going to replace this with an x. And you're going to replace that with a y. That's it. Okay? So when I do that, I'm going to write x equals the square root of 2y minus 3. That's it. Again, partial credit if you get this far. But Maria, if I want to just, get full credit, get 100 here, what am I going to do? Not yet. Okay? I have to deal with something first before I can deal with the 3. Okay? That radical. I got to get rid of the radical first. Okay? Because that negative 3 is underneath the radical. So I have to get rid of the radical first. What do I do to get rid of the radical? I'm hearing multiply. I'm hearing square. Which one is it? Square both sides. Just like the cube root up here is what I did to undo the cube root, or to the cube. To undo the square root, I'm going to square both sides. So I'm going to raise each side to the 2 power. Doing that leaves me with an x squared on the left. What does it leave me with on the right? Perfect. Just 2y minus 3. Exactly. Now what? Now square root. I'm trying to solve for y. Remember, Oshami? Add 3. And then I'm going to divide by 2. You guys got it. So add 3, divide by 2. Done. Perfect. And that is your inverse. And you can write it this way, or you can write it with the inverse notation. Either one is okay. Probably prefer it with the inverse notation, quite frankly, but that's fine. Okay? Inverses are pretty easy, don't you think? It's just switching x and y. That's all. From a graph or from an equation. Nothing more than that. So what I've given each of you is a review for your quiz. Okay? Or your quest, your twiz, your big quiz, your small test, however you want to deal with it. Your summative. Exactly. So if I want you to look at your review sheet for me, and let's make sure we understand everything that you can expect to see on it. Okay? This review is pretty much covers what's on it. Not a whole lot extra will be on the quiz that's not on here. So let's kind of look at it here. What do you notice about 1, 2, 3, and 4? What do those questions look like to you? The ones we did yesterday, doesn't it? Does to me. Add, subtract, multiply, divide, and then you have those composition. So we're going to, with functions, just like 1 through 4, actually it looks like 1 through 7 to me. Okay, you're going to have to add, subtract, multiply, and divide. I'd like to look at number 7 if we could. Can everyone look at that one for me? Look at number 7. Travis, you looking at number 7? Natalia, if I look at number 7, why does it look weird? What's different about number 7? The 2, okay? So I think we should talk about this one. So let's do number 7 together, okay? So we have 2 times g of x minus f of x. We've done g minus f, but we've never had the 2 there before. So we should probably look at that. How is that going to affect things? Am I going to multiply first or subtract first? That's our order of operations. Okay, so we know, please excuse my dear Aunt Sally, you multiply before you subtract. So let's take our g and multiply it by 2 first. So you do that for me. Take your g of x that's given to you in number 7 and multiply it by 2. Why am I putting f of x in parentheses? Because of the negative. I'm subtracting it. So I know I have to be careful when I subtract functions. Bradford, up here. Christopher, you're really distracting everybody that's around you, darling. I'm gonna have to sit you outside. I have to be careful of the two things that I'm highlighting. What am I going to do with the 2, Taylor? What am I going to do with that 2? Okay, and the word for multiply in this case would be distribute, because I got to multiply everything inside those parentheses. When I do that, Kimberly, tell me what I get when I distribute the 2. Perfect. Okay, so I've taken care of the first highlighted piece. Maria, why do I have that negative highlighted? Good. Good. Matthew, tell me what I get when I distribute the negative. We're on the negative. Tell me what I get. Is there a plus or a minus there? Okay. 5x, and then what? Very good. Okay. Am I done? Shamar, am I finally done? Why not? I got to add like terms. Okay. So I'm going to add the 6x and the 5x, and the negative 4 and the negative 2. That's done. Think you can do that? It's the 2, I think. I was afraid that the 2 would throw you off. That's not too bad. Right? Just have to multiply it first. That's all. All right, so we have add, subtract, multiply, and divide in composition. Look at number 8. That should look very familiar. We did that one almost exactly, except for we didn't do part C, right? So that's going to be something you're going to need to do. From a graph, can you do composition? Number 9 is a little bit tough. We'll come back to that one in just a second. On the back is all the inverse stuff. And we should be pretty good with that. Okay, so I'm going to go ahead and pause, let you guys work for a couple minutes. Numbers 4 and number 9 I'd like to talk about in about 5 minutes, 5-10 minutes or so, but I want you to work by yourself for a few minutes, and then we'll come back and we'll look at questions number 4 and we'll look at question number 9. Okay, but the other ones, at least look over those 2 before we get to them. Okay, so pause this while you guys work on your own for a little. You guys, if you look at the 2 word problems underneath problem 4, they're not numbered. Okay? So we need to treat those as like A and B. So that coupon pizza question is separate than number 4, and the discount is separate as well. So let's look at, we'll call this A and B underneath 4. So we'll start with A, and this is the pizza question. So put a big A next to that one. And then B is the discount question. They're just not numbered, but they are separate questions. So make sure you realize that, okay? My bad on when I type this up. Let's start by reading the pizza question and make sure we understand it, okay? It says you have a coupon good for $8 off the price of any large pizza. You also get a 20% discount on any pizza if you show your student ID. How much more would you pay for a large pizza if the cashier applies the coupon first? So let's write the coupon as f of x. So this is going to be our coupon question. How do I write the function for a coupon if I get $8 off? What would that be? Minus 8. So it's going to be the pizza minus 8. So x minus 8. That's the coupon function. Very good. Will, head up, darling. Now let's write another function talking about the discount. Okay. It says you get 20% discount on the pizza. It's not the same thing as a markup like we did on the last question, right? When you marked up, you added the percent to 1. That's where you got 1.25 from. But now we're getting a discount. It's actually not negative. You're subtracting it from 1. So actually 1 minus 20, or 100% minus 20% is what? 80%. So it's actually, you're paying 80% of the price if you get a 20% discount, if you want to think about it from that perspective. So it actually becomes 0.8x, because you're paying 80%, because you're not paying that 20%. You subtracted it. That's your discount. If it was a markup of 20%, what would the number be? 1.2. Okay? Good. So these are my two functions that you need to use. You will not have enough room on this sheet of paper to answer either of these two questions, so you will need to staple that here to the paper. Okay? So if I'm looking here at the question, it says, how much more would you pay for a large pizza if the cashier applied the coupon first? So if I wanted to do the coupon first, is that g of f of x or f of g of x? Okay, so I'll just write. Let's just write them both, and let's see if we can decide. F of g of x or g of f of x? Which one is the coupon first? It's the one where f is on the inside, because you do that first, right? So this is going to be the coupon first. So tell me how much the pizza would be when you do the coupon first. Then I want you to tell me how much it would be with the discount first. And then the question says how much more, what are you going to do with those two things? I'm going to subtract them. Which is really kind of important for you. If you have both a coupon and a percentage off, you want to know, you want to be able to be a good consumer and pay less, right? So you want to know which one they should apply first, if that's even possible. Yeah, this is something you do in finance. Math and finance all comes together. Okay? So that's going to help you with problem number 4, or A. Okay, so I'm kind of helping you set up that problem. If we look at B, a little bit different. B is a different problem. So make sure you're treating it totally separate. It says a store is offering a 25% discount on all items, but also employees get a 15% discount. If you are an employee, which one would you want to be applied first? So let's write those equations. Let's do our employee discount. Let's write that as f of x. What would the employee discount be? 15%. If it's a discount, 0.85, right? So it's a discount, so 0.85x, because you're paying 85%, right? Yes, 100 minus 15, that's exactly right. And then the next equation, we're going to do just the regular store sale, the store discount. We'll call that g of x. And it says we get a 25% discount. That's what the store sale is. So which one, what would the equation be? 0.75x. Very good. And you're going to do the same kind of thing that we did in problem A. You're going to find f of g of x and g of f of x. And you're going to figure out which one I want to do first. F of g of x, which coupon is being applied, or which discount is being applied first with f of g of x? The store is first. So we're going to write that. That's the store first. How about g of x? I'm sorry, g of f of x. Which one's being applied first? The employee discount first. And so you'll just find both of those and just decide which one, as you're the consumer, you're the buyer, which one would you want them to apply first? Which one will save you the most money? Okay? Helpful to set it up like that for you? Okay. All right, so that was it's after problem 4. We just called it A and B. I wanted to at least set them up. They're not complete in any fashion. You still have to do the work, okay? So I'm just setting it up, helping you set up for you. Number 9 is the other one that I thought you might struggle with. So before you go home and work on this review for your TWIS, let's look at number 9. Exactly. Okay? We have a function. Y equals the radical 3 minus x plus 2 squared. It says I want you to come up with two functions, f of x and g of x, so that when you compose them, when you find, oh, this is something I need to tell you, I guess. I didn't even tell you this. Shame on Mrs. Mackert. So this is, I'm glad we went over that. I forgot to tell you this. This has to do with inverses. Important information. It's asking you to figure out, if I did fog, what is fog, by the way? What's another way to say fog? F of g of x. It's a composition, right? And the other one is just the other way around. If these two things equaled each other, if I composed in one way and I composed in the other way, we don't always get the same thing, do we?
No.
Often we don't get the same thing. But if they are the same, then these are inverses of each other. So if the compositions are the same, you should probably write this down in your notes somewhere. If these are the same, then f and g are inverses. That's pretty darn important. Okay? So if you did the composition f of g of x, and you did the composition g of f of x, and you got the same thing, actually they'll both be x, believe it or not. Okay? If you get the same thing, then they're inverses of each other. Oops, I erased the g somehow. So if you look at question number 9, it's really just a big fancy way to say what? It's really wordy, but it just basically means in number 9, find the inverse. Let this one be f, and I need you to find the inverse. Okay? So that's really what the directions are telling you to do, because the compositions, they say, are the same. Okay? So that's your clue on number 9. Just find the inverse. But again, it's just a strange way of writing it. Are we good? I won't. I'm just going to leave it up here for you. At this time, I'll need the calculators. Your homework, by the way, is just to work on the review and study for your TWIS. Okay? Real quick, guys, there's one more thing I can fathom possibly being on this TWIS thing, is domain and range. So just make sure you realize domain is all the x values and range is all the y values. That is something else you could possibly see. And is it a function, yes or no?